so Test Friday. There's 2 review packets here. This is for both days, today and tomorrow. I just went through and I grabbed every Regents question I could find. Okay, so just to kind of recap on what we've talked about. So we spent, when we first started, we just started putting things in our calculator. We talked about the mean, the median, mode, etc. And then we got into those normal distributions, okay? And we started adding all those percentages, and we said, that's what we used to do. Now we have a button on the calculator to do that. So you never should be adding percentages again. Your calculator is doing all of that. Then we got into all the graphs over the past few days, the margin of error and the confidence intervals. So let's start with this packet that looks like this. Okay, we're going to answer a couple together, just kind of get, again, a little practice here. So number 1, the weights of the bags of the chocolate candies are normally distributed with a mean of 4.3, a standard deviation of 0.5. What is the probability that the bags weigh less than 4.27 ounces? Okay, so let's kind of talk about what should be highlighting on our paper. The words that jump out to me right away are normally distributed. The moment I see that, my brain is saying, use normal CDF. Okay. That's my indicator. And it gives me the 4 things. The 4 things I need are a mean, a standard deviation, a lower, and an upper, maybe not in that order on the calculator, but it gives me 4 important keys. So the mean, the standard deviation, the lower, and the upper. So let's highlight what we know. What is the mean? Okay, so I know my mean is 4.3. My standard deviation, again, I'm underlining as I read here, is 0.05. And now I'm looking for the probability that I'm less than 4.2. So if I kind of picture my curve and I found 4.2 and I said less than, I'd be shading to the left. So what would my lower be if I went forever to the left? And how are we going to put that in our calculator? 99999. Yep, and my upper is going to be 4.27. Okay, so there's lots of different types of stats question, but to me, these ones are kind of obvious. They say normally distributed, and they give me those 4 details. So now I'm just going straight to the calculator. We're not adding anything by hand. Where do I find that normal distribution? What do I have to hit? Or norm CDF? Yes, second distribution. Okay, we're only using CDF, so norm CDF, and plug those in your calculator appropriately. So I'm going negative 999. What was the upper? 4.27. Mean is 4.8, standard deviation 0.05. How does that compare to everybody's 0.2743? Yeah. Easy. I mean, I love seeing these questions on the exam. I'm only going to see one of them, but they're pretty straightforward. Take a minute and do 1 through, oh, we did 1, 2 through 4. 2 through 4. Read the question and highlight what we need there. All right, how did for 2, I think I got A. How does that sound? Does anyone need an explanation? For 3, I think I just had that one up. I had 0.022 or 2.2%. D? Hold on, let me just finish 3. Does 2.2% sound good? Anybody on 3?
Would that just be 2? It would be
Yes, it would be B. Yep, 2.2%. You want me to do 2? I'd 4. Oh my gosh. Sorry. Oh my goodness. Why is this not going? All right, so I have 1440 is my min. 1465 is my max. The mean is 1450. Standard deviation is 8.5. I think that's 84.14. Right now you're getting a different number? Pass your calculator up. You don't have the first number typed in right, silly. The first number's not right. You have 1140. It's 1440. No, you have 1140. Merrick? All right, number 4. The scores on a mathematics college entry exam are normally distributed. So there it is again. So I'm thinking normal CDF. I've got the mean is 68. The standard deviation is 7.2. Students scoring higher than 1 standard deviation above the mean will not be enrolled. How many of the students are expected to be enrolled? Okay, so this one, they're not like coming out and just giving you all the numbers. You have to write this out first. So let's draw out our curve because they didn't give us everything. What always goes in the middle? The mean. So I'm going to stick 68 in the mean. Okay, and my standard deviation is 7.2. So it says students scoring higher than 1 standard deviation above the mean. So where should I go? To the right, 7.2. So 68 plus 7.2 should get me 75.2. Okay, so let me read this again. Students scoring higher than 1 standard deviation will not be enrolled in the math tutoring program. So if you're over here, you are not enrolled. It says how many students can be expected to be enrolled. Who do I actually want to find? Everybody else. I don't care about the people not enrolled. I want to find all of these people that are getting enrolled in the tutoring program. So do I have a min or a max? The max should be 75, and I'm going down negative 999. Okay, so these are the people not enrolled, but I want the people enrolled. So I'm going to go negative 99999 to 75.2 with a mean of 68 and a standard deviation of 70.2. Okay. So what percent of the students are getting enrolled in the program? 84. Now it wants to know how many students. Notice that's not a choice, that's not the question. How many of the 750? So what am I going to do with that number? Times by the 750. So 631 students are getting enrolled in the tutoring program. So they're not always going to be super straightforward and tell you what they are. They might make you work at it a little bit. Okay. I'll give you a few minutes to try 5 and 6. No. should be able to answer. I don't think they have anything to do with a normal distribution. Especially the first one. Let me read the second one. Oh, the second one, you should just know. Question 5, what are they asking you to find? The confidence interval. The 95% is your confidence interval. That's what we spent the past day and a half talking about, confidence interval. How do you find a confidence interval? Who do you start with? So the margin of error is 2 times the standard deviation. Which of those represent the standard deviation? 115, right? It says the mean, the mode, and the standard deviation. So 2 times 115 should get me 230. Okay, and now what do I do to get that confidence interval? What do I do, though? Who do I start with? Excellent. The mean plus the margin of error, and the mean minus the margin of error. So the mean is which number it said? 496. So that eliminates those 2 choices. We never use the mode. So it's 496 plus my margin of error, my 2 standard deviations. And again, that's really just the definition of that confidence interval. Number 6 are 400 students in the senior class. All these students took the SAT. The distribution of SAT scores is just approximately normal. The number of students who scored within 2 standard deviations of the mean. So what percent should be popping in your head? 95%. Now, don't pick 95. These aren't percentages. I know 2 standard deviations is 95% of how many students? Of the 400 students. So I need 95% of the 400 students. The only one that even makes sense, if I took 95% of 400, this is the only one that's even close to it. Okay. All right, so we spent one day just kind of going through that normal CDF. We actually spent 2 days doing that. We spent one day on what we called statistical studies. So you can see how they're asked. Again, these are all Regents questions. Which statement about statistical studies is true? So I want you to take a moment to read each of those and come up with the one that sounds the best to you. And if you're not sure if you can think of which one's the best, which one seems inappropriate, which one seems like it shouldn't work?
3.
Okay, talk to me about 3, Peyton. Why do you not like 3?
Because it's talking about how it's a long period of high schoolers and it would be tracking the adults. So,
Yeah, does that make any sense?
no, because high schoolers aren't technically adults unless they're 18, which is senior year only.
Right, so if you ask high schoolers what they think about adults on social media, like that's really not an appropriate use of information. So that one is definitely false. Who's got another one they don't like? Miles?
4 is biased.
4 is bias. Let's see. A survey of all calculus students would be a good example to determine the number of students who don't like math. But yeah, why would that be bias?
Because in calculus and it's not a required course.
Right, it's an elective course, and they're probably really good at math if they're in a calculus course. So that would be a bias. That would be terrible, too. All right, so we're down to 1 and 2. So that's going to cross off these 2 choices. Merrick, I'd love to hear what you think.
I think it's B.
You think it's B. Does anyone agree with Merrick?
Yeah.
Well, Merrick, hold your thought here.
Yeah.
You're asking ninth graders who can't drive about parking? Does that make any sense? I think that's a total bias. That's not a great example. Ninth graders don't know anything about the parking lots. They can't even drive. Number one, a survey of all English classes would be a good sample to determine the number of hours students throughout the school spent studying. What word kind of makes this a good example? You're asking all the English classes, right? So you're hitting every grade when you ask all the English classes. So you're getting a random sample of everybody. So I'm going to hit random sample. So I think the best one, okay, you may not like any of them, but the best one is going to be choice 1.
What would be better is if it was all classes, not just English classes.
Well, again, if you hit all classes, that would be really hard to get every single class. That's why I think they're limiting it towards the English class, because you're hitting a variety of people.
Would the second one be correct if it wasn't a survey and you just put how many students that had?
No, I mean, I think what kills it is you're asking ninth graders who don't park.
No, I mean, like, if it wasn't a survey, if they just took the number of students that had in ninth grade for future parking spaces.
I don't think so. I still think it has something to do with the ninth graders.
Yeah, parking those-
You're asking 13-year-olds about driving.
For the, like, class size class.
I don't think so, Miles.
I'll help you figure it out.
All right, you guys got the next page, 8 through 12. Let's put like 4 or 5 minutes on the clock. 8 through 12. Read each one carefully.
Michelle,
So again, we spent this whole day talking about types of studies, and the big takeaway that you had to understand is this cause and effect. If you have a cause and effect, what did you have to have? Had to be an experiment. So in 8, which one should we be saying is false? B. Okay, so good for you if you've got that cause and effect can only come from an experiment. That is your real, true source of data.
I thought it would have been B. I thought it was B. Yeah, me too.
Oh, yep. I'm looking for false. False. Thank you. Thank you. Jiminy crickets. Sorry, Sarah. Sorry. All right, number 9. All right, so this one kind of scared me walking around because I thought this was very obvious. Question A. Give me the one key word in here that tells me what this is. Ask. What does ask tell me? Survey. The moment I saw ask, I should be taking a survey. So clearly, that's not an observational study. I thought there was another one that was super obvious. How about D?
D is,
What's the one keyword that gives away what it is? Questionnaire. If you gave someone a questionnaire, you're giving them a survey. Okay. Now, I think there's a big difference between B and C, and we are looking for observational study. A social researcher wants to learn whether or not there's a link between attendance. She gathers data from 15 school districts.
She's not changing anything, she's just
yeah, he's watching.
So if you're watching, you're what? Okay. Letter C. We divide them into 2 groups. One gets a calculator, the other doesn't. What did you just conduct? Experiment. I'm walking around, I see half of us circling C. That is not an observation. The moment you separate into 2 groups and you give one group something and another group something else, that is an experiment. Okay? This would be, we're just sitting back in our lawn chair and getting our answers. Okay? And you're observing. 10, which investigation is the most often used? Which is the most important? That's the only one that can give us any relationship. Controlled experiment, cause and effect, yes, B. Okay, and a controlled experiment is the only thing we can really get our data from. Number 11, a veterinary pharmaceutical company plans to test a new drug. Puppies are randomly assigned into 2 groups. Half the puppies receive the drug, the other half receive a placebo. Controlled experiment, again, the only thing I can get a cause and effect from. Number 12, a random sample of 100 people would be the best proportion to find voters, well, they want improvements to the softball field. All right, who would be the best group to pull from if I want a random sample? Why not a high school football? Why not a football game? It's biased because you're asking about the football game. Why not a high school band concert? Well, maybe not be against it, but they go to the same school, so that would be a bias. School fundraiser. Bias because you're still trying to raise money for the school. Does everybody need to eat?
everybody's eating.
Everybody's going to go to a supermarket at some point. Whether or not you're for the school or against the school, You're going to go to the supermarket. There is a random sample at the supermarket. All right, let's finish this sheet off here. 13, Chuck's, so these are some short answer questions. Chuck's Trucking Company has decided to initiate an Employee of the Month program. To determine the recipient, they put the following sign on the back of a truck. How's my driving? Call 155 for driving. The driver who receives the highest number of positive comments will win the recognition. Explain one statistical bias. So go ahead and write one bias. Write it down first. One bias that you see here. Why is this not a good method? What is a bias that could be happening? How do we come up with 10 different ones, but come up with something. Peyton, what's the bias you thought of?
Not everyone calls.
Right, as we call that the voluntary bias. Not everyone's going to call, right? You might call if you're friends with this guy, or if this guy was driving down the road and cut you off, then you might call and let him know how you think his driving is, right? It's optional. You don't have to do it. Anyone else have another description of it? Dree?
Not super confident in this one, but I said that the drivers who like work more hours are more likely to get comments.
Yes, I think that's 100% true. Yes, that's a great answer. Merrick?
The driver called himself.
The driver could call himself. He could just keep calling in and say, what a great driver this person is. I like it. You got it. That's great. Those are all great answers. Okay, so like I said, you could probably come up with a bunch of different answers. Just sell it as you're writing it out to whoever's grading this paper. There's almost no wrong answer. Okay. 14, an orange juice processing plant receives a truckload of oranges. The quality control team randomly chooses 3 piles of oranges, each containing 50 oranges from the truckload. Part A, so take 30 seconds, identify the sample and the population of this scenario. The sample and the population. What would the sample versus the population be? Just say that one more time, I just didn't hear. Yeah, so the population, is population part or total? Total, so this would be the whole truckload of oranges. Okay. And then my sample, it wouldn't even have to be 3 buckets, it could be 1 bucket, it could be whatever, it could be part of the truckload. I'm just going to say a bucket of oranges. 150 what am I trying to say? Bucket of 50 oranges? Yeah, sure, that's great. Okay. Just again, population is the total, the whole total, and a sample is a small part of them. State one conclusion that could be made about the population if 5% was unsatisfactory. So if we said 5% is unsatisfactory, which means, yeah, I would say 95% is satisfactory. So the majority of the orange are satisfactory. Easy enough? Okay, so if 5% are unsatisfactory, that means 95% are, which is the majority of them.
I often wonder what they make that is satisfactory.
Probably the weight, the size, shape. What?
Here you go over your head.
Yep. Just did, Dree. Just got it now.
The word satisfactory.
Yep. Got you, Dree. Dree, you're a gem. All right, go to the second packet. We're going to tackle a couple of these in here. Let's start with 6. So flip to page, or question number 6. Question number 6. Okay, read it to yourself. Everybody should get this question right. It should be a nice, simple one. Question 6. They give you the information. No one should just be ballparking. I see some people trying to ballpark it on there, like, get the actual numbers. All right, so again, I think this is a really nice question. The moment I see 95%, I'm finding a what? Confidence interval. What do I find first? Margin of error. What's my margin of error going to be? My margin of error is 0.12. And then to get my confidence interval, it's the mean plus the margin of error and the mean minus the margin of error. Which choice does that lead us to? C. Why do we have B? What did you do?
I did it wrong. I know I did wrong. I didn't do that mark.
Why?
I don't know.
If you don't want.
95% confidence interval.
All right, thanks.
All right. Number 7, read it to yourself. So again, you're going to see that these all look very similar, all these word problems, okay, where it's non-calculator. Radio station claims its advertisers that the mean number of minutes commuters listen to the station is 30. The station conducted a survey of 500 listeners, and it's shown here. Simulation was run 1,000 times. All right. Circle this for yourself. The moment you're seeing the mean and the standard deviation, your gut should be saying, I bet the question's going to ask for a what? Confidence interval. That's usually the question every time. Based on the simulation, is the claim that the commuters listen to the station 30 minutes plausible? Write yourself a confidence interval of the middle 95% of the data. So take a minute, write your confidence interval, and then answer the question based off that one statistic. Now it does, here's where we get people all the time, and not that we get them like in a mean way, but they lose a whole point on the exam because they don't read how to round. They want you to round your middle 95%, your confidence interval, to the nearest hundredth. I can't tell you how many 99s we get on this exam for a rounding error. Read carefully. What should my lower bound be? 23 to the nearest hundredth.
And then it would be 30.97.
30.97. Okay, so again, make sure you read the rounding. They usually tell you on the confidence intervals what to round to. So now it says, based on the simulation, is the claim that commuters listen to the station on average 30 minutes plausible? So what do I want to do with this 30 minutes? I want to see if it fits in here. So is it plausible? Okay, so we're going to say yes. What about boring? That's okay with you, Rohan. Boring. And now talk about the data point. You have to talk about 30 in your answer. 30 minutes falls within the confidence interval. I'm going to put 95% confidence interval. So 30 minutes is usual. Okay. You've got to talk about that one specific number they gave you in your interval. So 30 minutes is usual. All right, flip the page. Try number 8. So again, read it to yourself. See what they give you. We'll compare in a few minutes. Rounding on your interval. Alex, what was your margin of error? That's your confidence interval, just your margin of error first. 15.9, so again, 2 times the standard deviation. And then your confidence interval you just said was 1 to 155, and it said round to the nearest integer, right? Okay, so now we got to read part B. A study claims that 50% of the men are married. Does your results contradict this claim? So they didn't tell us what number. We have to figure that out. We need 50%, jot it down, of the men. How many men did they ask? 250. So I need 50% of 250. Give me 1 second. So what number are we comparing? 125. Where does that fall? Inside. So again, we're going to say that is usual. Okay, boring. Yes, thank you. Boring and usual. That 125 falls within the confidence interval. Let me be clear. This is not homework. You're just bringing this back tomorrow. Okay, you've got a spiral to work on. That's your homework. This is not homework. Just bring it back. Have a great day.